Hello, my lovely viewers. Welcome to my station, spoken by Abby. I'm yours truly, Abby, and today you are in Miss Abby's Science Corner. Now, today we are going to do a lesson in chemistry. The last time we were in Miss Abby's Corner, we did biology. Now, if you have been watching my videos, you would have realized that I'm not just a poet or someone who provides motivation on this station, but also a tutor or a teacher. So I decided months back that I wanted to share a few lessons. I would have said that in that particular lesson that I did before in biology. That was a grade 7 biology lesson. Now today I would like to share with you a chemistry lesson, grade 8 chemistry lesson. And the reason why I'm doing this is in regards to the direction that I see education going in regards to the virtual capacity and also the STEM program in education, which speaks to science, technology, engineering, mathematics, and combining all four areas to equip students to have a career and just considering the real world application of what they learn. And it's all about being hands on in addition to a strong theoretical background. So today's lesson, it will not be complicated. It will be just the basics of this lesson. Maybe some student out there don't have consistent access to the internet, but every now and then they can view YouTube. So here's another YouTube station that caters to education, especially in the Jamaican context, because the content that I have here is based on the Jamaican curriculum for I'm going to do from grade 7 to maybe 9 or 10 whenever I feature a video in Miss Abby's Science Corner. Now, going into the lesson, the background of this lesson is coming from biology, and that's how the STEM also comes in, where atoms, they are considered the basic elements, if for better want of word, it's not really an element, but the basic element of life. Everything around us, we were taught from biology that everything is made up of an atom. All right. So we're gonna talk about the atoms and elements of the periodic table in this lesson. Now, the objectives I have here, and there will be two. I'll be splitting this lesson into two. So at first we're going to talk about identify the first 20 elements along with their names, their symbols, protons, neutrons, electrons, and mass numbers. And when we finish that, we will speak to writing electronic configuration for these same first 20 elements. So we will know that based on viewing different diagrams, and I'm going to show you a diagram that I have here, the periodic table. There are many elements, and I think yearly, probably monthly, scientists are coming up with new elements. They may not have been implemented into the periodic table as yet, but they are out there. And if we can remember, students as adults, the adults listening, and even the students coming from maybe grade 7 can remember, they learned that Mendeleev was one of the scientists that was able to develop the periodic table along with his colleagues in order to, group, so to speak, different elements so that they can be easily identified. So if we also go back to biology, where there's a similar concept about grouping organisms, we see where the stem is also coming out, the connection with everything. So all the sciences is linked. And in the future, just a side note, I plan to also do some physics lessons as well. All right, so looking at this periodic table, very colorful. Like to just point out a few basic stuff. Again, this is just a basic lesson. For the more in-depth concepts, students, you need to listen in class and you need to be reading your material. So we have the periodic table. It has groups and periods. Now the groups, they are longitudinal. There are up to 18 groups. Some are numbered and some are not. Some of the more common groups that we have heard of, they are metals, non-metals, alkaline metals, alkaline earth metals. Those are two different ones. Sometimes persons mess them up, but they are different. And you also have noble gases as well. For the groups, the periods now, you have 7 of them. And these are latitudinal, meaning they go from top to bottom. And let me just point it out on this diagram. So you have, for example, it's not going to show everything, but all right, so there we go. So you have period 1 to 7 from top to bottom. So you have helium in period 1. I'm sorry, I keep saying groups. It's because mainly we focus on the groups rather than the periods, even though the periods, they are very important as well. So you have period 1 helium, lithium, period 2 sodium, period 3, etc. If you go across, for example, you see magnesium is in group 2 and so forth. Most of these in the middle, they actually don't, some of them don't have particular names like metals and so forth. Some of them are non-metals as well. But again, when you view the diagrams, you will see where they are annotated to show you which is what metal, or which is what element in which group and period. Now I also want to point out that elements in their respective groups and periods usually have similar physical and chemical characteristics, and this is usually due to the number of electrons on their outer shells, and we are going to talk about that in group 2 in regards to electronic configuration. And when we talk about electronic configuration, it is not going to be like in-depth, because this lesson is for grade 8 really. It's not going to be as in-depth like the concepts for electronic configuration that maybe grade 10 or 11 will learn in chemistry. Alright, so we're moving on to the next slide. Alright, so there we just have listed the first 20 elements of the periodic table. They are hydrogen, helium, lithium, which is Li, beryllium, Be, boron, B, C for carbon, N for nitrogen, O oxygen, F fluorine, Ne neon, Na sodium, Mg magnesium, Al aluminum, Si silicon, phosphorus for P, sulfur S, Cl chlorine, Ar argon, K for potassium, and Ca for calcium. So the first 20 elements. Now, and it's the first 20 elements because we are really looking at the atomic number. So they are categorized based on their atomic number, and that's how we are focusing on them here. All right, so if we look at the diagram closely, we will see here that what is listed under each is that for example, you have helium, which is number one atomic number, one proton, and one atomic mass number. If you maybe go to oxygen, you will see where atomic number is 8, proton also 8, atomic mass would be 15.99, but you know that will be rounded off to 60. So we can do further research into that, and we are going to proceed with the lesson for more clarity. So before we do though, here's a quick activity you can maybe practice. You can pause the video to try based on what we just spoke about and your additional reading. Identify the elements of the periodic table which these items consist of, partially or fully. So you see a picture there of a banana, see one of a can, a soda can. You see there's a gas gauge, and then you see a pool there. So you know, if you're really thinking about it, you're not thinking about it on the surface level, you will be quick to pick up which one of the elements is depicted in each of this picture. So you can just pause it, and then you can go ahead to answer the question. But for time being, as this video is ongoing, for example, we look at the can. First thing that would come to your mind is a metal, and that would be aluminum. So there we go, that's the element that is represented by that can. So you can figure out the rest. All right, so next, so we want to also quickly look at the nuclear annotation before we finish this part 1. So we have, if we were paying attention to the previous slide 3, which we identify the elements by letters, we will see where that would have been a representation of the chemical symbol for each element. So what happened is, if it's a single letter, you would see it in capital. If it's 2 letters, you will see it in capital, and the second letter would be in common. So that would be the chemical symbol. Now we also would identify that last slide did not have the mass number and the atomic number as in this form, but just to let you know, when it's represented, it would be in superscript and subscript. So the superscript would be the one on top, the mass number, which is equal to atomic number Z, represented by Z, plus the neutron, represented by N. And we will realize that atomic number is also equal to the number of protons. And although it's not here, I'd like you to know as well that in a stable element or atom, you will find where the atomic number would be equal to the number of electrons, which is also equal to the number of protons. So when we are going over into electronic configuration, we need to keep this in mind so that we will be able to deduce or figure out which element we are trying to represent. So that's it for part 1 of the lesson on atoms and elements of the periodic table. See you in part 2.